Hello everyone. In the last video we saw how we can find the time complexity of any basic for loop. In this video we are going to see how we can find the time complexity of any complex for loop. So if you have not watched the last video, I recommend you to watch that video first and then come to this one. So let's start. So let's say our first example, which is the same example from previous video. Here we saw that this initialization will run one time, this condition will run for n plus 1 time, and this initialization will happen n times. So what we get from here? We get n plus 1 from here, and this statement will run for n times, because n plus 1 is only checking the condition, is how many times the condition is checked, but how many times the loop will run? It's n times. So summing this, so we get our function fn as 2n plus 1, and from here we found out the time complexity is big O of n, or order of n. So now let's see our another method. So let's trace it step by step. First, our I was initialized to 0, so I will be 0. Then how many times the statement will run? Because it's just initialization, it will run for one time. Then after incrementing, I becomes 1. How many times the statement will run for this 1 I equal to 1? It's also one time. Then we check 2, statement will run for one time, because it's a loop, so it continues till n. And at n also, how many times the statement will run? It will run one time. So now if we sum all these, so we can write here that it's 1 plus 1 plus 1 till 1. And how many times this is? We can see here that it's n times. So we can write here it's 1 multiplied by n, which just equals n. So this is nothing but how many times our statement executed, this statement. We can see here that it's n times the statement has executed, and here also it's n. So we can directly say that our time complexity is of big O of n, or order of n. Now let's see our same loop, but this time what we are going to do is we will reverse this loop. How? We can say that I is initialized to n, and I will run until it is greater than equal to 1, and I minus minus, I is decrementing. So here it's also same, that I will be initialized to n, the last element or the last iteration. It will only run one time. Then again I will decrement n times, because it has to reach 1. Then this condition will check for n plus 1 times. So this for loop will execute for n plus 1 times. Then this statement will obviously run for n times. Statement will be executed for n times. So if we sum all this, we can again get the time complexity as order of n. Now let's see this example. With the same loop, initialization at 0, it will run for one time. Condition check, it will run for n plus 1 time. But here we can see that it's incrementing by 2. So what we can do here? We can check with the same method, and then let's start with I equal to 0. Then how many times the statement will run? It will run one time. Then the I will become 2, not 1. So it's 2. Statement will run for one time. And similarly we can reach here, like this we can reach n, and again the statement will run for one time. Now we can see a pattern that when I is 0, it was 1, 2, 1, n is 1. So what is happening here? It's 1 plus 1 plus 1 plus till 1. So it's happening. So it's happening that I is initialized to 0 and it's reaching n, and by what it is incrementing? By 2. So every time I is increased by 2. So we will reach here. We can say that when it is 1 multiplied by n by 2 times, we have written this 1 plus 1 plus 1, 1 into n by 2 times. So from here, our function becomes n divided by 2. But from here, time complexity, we have to find the time complexity of this for loop. So it's big O of n only. It is big of n or order of n because we have to drop all the terms or the coefficient. So here the coefficient is half, so we dropped it and just write the polynomial and just write the variable with the highest degree of that function. So we got order of n. So we can say that this condition, this incrementation will happen not n by 2 times. But what if our loop was incrementing by 20 or let's say 100 or even 1000? What would happen? Let's take it 100. So how many times this condition is running? So we can say that this incrementing will happen for n by 100 times. So here we can say that this will then become 100, and again this will happen like this, and this will happen for 1 into n by 100. So our function becomes n by 100, but our time complexity will remain the same because we have to drop all the coefficients and other terms. So it's order of n. Also, what if the for loop was in reverse? Instead of incrementing, it was decrementing. Then no difference. It will still run for n by 100 times. The function will be n by 100. Then still our statement will execute it n by 100 times. Our time complexity will be order of n by dropping all the constants, all the coefficients or the terms. So let's say our next example. Here we have a for loop which where is its condition? It's depending on another external variable. Let's test it. So first I is initialized to 1. Here I is initialized to 1, so I will become 1. Then our condition will check it if the loop will run or not. So p is less than equal to n. Let's assume n is a large number and p is 0. So 0 less than equal to a large number is true, so it will execute it. So our final p will become initial p plus I. So what it is? Final p will become 0 plus 1 because I is 1. Now I will be incremented. So here it will become 2. Now p was initially 0 plus 1, but now it will become final p equal to initial p, which was 0 plus 1 plus I. Here I is 2. So it will become this 0 plus 1 plus 2. And similarly, we can say that it will go till, I'm not using here k, I'm not using here n because we don't know how many times this loop will run. I'm using another variable which we can call k. So here we can say that finally our p, when the I reaches k, p will be executed for 0 plus 1 plus 2 plus 3 plus till n, not n, k. So here we can assume that at some point p will become greater than n. Let's assume this. Then only our for loop will stop. So how many times the p is running? It's running for 0 plus 1 plus 2 plus 3 till k. So what is this? It is the sum of first natural numbers. This equals k into k plus 1 divided by 2. So we assume that p is greater than n. So we can assume that k into k plus 1, this is greater than our n. So what we will conclude from here, to find the time complexity, we have to drop all the other lower degree variables and also the constants, other terms. So we can write this as k square greater than n. So if we take square root both side, this will become k equal to 210. So we have to calculate the time complexity of this. We can say that the time complexity of this in terms of n is big O of root n. So here is our time complexity for this algorithm. That was all for today. From next video, we will see some more algorithms and find the time complexities. Thank you.